One of the things that I really love about astronomy is that it is super cutting-edge modern, but it is also extremely ancient. Almost all of the ancient societies that we know of had some sort of astronomical tradition. For example, in this image, we're looking at the sun dagger. This used to be found in Chaco Canyon, New Mexico. I say used to because there was some shifting of rocks in the last few years, so this doesn't actually happen anymore. But what we actually see in this image is this nice bright line of light covering over what appears to be a spiral that has been carved in the rock. Now, on the day of the summer solstice, if you remember from previously, the summer solstice is the longest day of the year when the sun is the highest in the sky and farthest from the celestial equator. You actually get this nice bright line of light that goes straight through the middle of the spiral. However, as you move away from the summer solstice, then the line drifts away from the center of the rock, and after a while actually splits into two separate pieces. And so what we think happened is that somebody noticed this movement of the light in this little cave area, and so they carved the spiral to help keep track of time and day and season. Now, we don't know that for certain. We don't know exactly who did this, but it appears to be something like that. In this image over here on the left, this is El Templo Mayor. This was an Aztec temple that used to be located in Mexico City. Now, the Aztecs were a sun-worshipping people, and we actually have written records that on the day of the summer solstice, the sun would actually rise between these two upper pyramids. Well, being a sun-worshipping people, you want to know what day is the summer solstice, so they kept track of that sort of thing. On the left over here, this is Stonehenge, and if you're like me and you watch late-night TV, then you know that Stonehenge was built by aliens for some known and mysterious reason. Okay, no, not actually aliens. We don't know exactly who built Stonehenge. The best records we have refer to the Druids, and that's not at all helpful because the Druids aren't a defined people in any way. But we know that it was built at some point in the past. And as we've studied it, we've noticed that the stones actually line up with different days and times of year, not just with the sun, but also with the moon and even bright stars. So, although we don't know exactly why Stonehenge was built or what it was used for, it does seem to be keeping track of time and season and other astronomical events. Although lots of different civilizations have astronomical traditions, we're going to be following through what the Greeks did. Now, the reason for this is not that the Greeks were inherently better than anyone else. They absolutely weren't. But their ideas and thoughts are what has led to modern science and our current understanding. So we're going to be following the Greek tradition because that's kind of where our history has been. Now, the Greek philosophers started what, again, has led to modern science. Some of the things that they did that have led to modern science is they tried to explain things through natural phenomena, through natural cause and effect. Okay? They tried to move away from explanations using the supernatural. Okay? So invoking demons and goblins and ghosts and that sort of thing to explain what's going on. Something else they began doing is they began using mathematics to help us understand and predict what is happening in the world. So if you've ever had to read through a math problem, one of the story problems, and figure out what's going on, you can blame the Greeks for that. They're the ones who started it. They also understood the power of reasoning from observation. Observing the world, and then starting to figure out if we see this and we see this other thing, what does it mean about the world when we combine them? Okay, so our ideas of logic and reason are actually rooted in ancient Greek tradition. Now, all of these ideas led to models. A model is a representation of what you believe is going on, and it can help you get an idea and a feel for what's actually happening. Okay, so as an example, if I talk about an atom, you probably kind of get an idea of what an atom is, with this tiny thing at the center and these other things zipping around or on the outside. Now, that's not exactly what an atom is or how an atom behaves, but it's a good representation to help us understand what atoms are doing and their general structure and so on. So this is the idea of a scientific model. We often get the idea that the people anciently were very primitive, but they actually had some really good ideas and were able to make some very astonishing discoveries. For example, an astronomer mathematician by the name of Eratosthenes was actually able to figure out the circumference of the Earth in 200 BC. And so the way he did this is he knew that there was a particular city named Syene, and on a particular day of the year, the sun was exactly on the zenith at noon, meaning it's directly overhead. More particularly, it was known that things did not cast shadows on that particular day, and you could see all the way to the bottom of a well using sunlight. But this means that the sun was exactly on the zenith. It was also known that in another city, Alexandria, which was a known distance away, the sun was not exactly on the zenith on this particular day. So we knew and know exactly how far it is from Syene to Alexandria, and we know that on this particular day, the sun is directly on the zenith in Syene and is not in Alexandria. So what Eratosthenes did is he had an assistant go from Syene to Alexandria, and at noon on this particular day, the assistant held a stick, so actually set it on the ground so the stick was pointing perfectly up towards the zenith, and then measured the shadow of that stick. So we know how long the stick is, and we know the length of the shadow it's making. From those two, he was able to figure out the angle from the zenith to the sun in Alexandria. So specifically, the angle between the zenith and the sun was 7 degrees. Well, using a little bit of geometry, Eratosthenes was able to show that the 7 degrees between the sun and the zenith as measured in Alexandria is the same angle between Syene and Alexandria as measured from the center of the Earth. So if you're at the center of the Earth, the angle between Syene and Alexandria is that same 7 degrees. Then we know the distance between Syene and Alexandria, so it's just a little bit more geometry to then fill in the rest of the circle. And in that way, he was able to determine circumference, and then it's just a little bit more geometry to go from circumference to diameter and then radius. Something else that they started to do was start figuring out the distances to the sun and the moon. So around 280 BC, the astronomer-philosopher Aristarchus actually figured out a way of determining the distance and sizes of the sun and the moon. So particularly what he realized is that during first and third quarter, the angle between the Earth, moon, and sun made a perfect 90 degrees. If you've ever had geometry or trigonometry, we love 90-degree triangles. It makes all of the math way simpler. So we now have this nice right triangle. What he needed to do to start filling in the circle is to measure the angle, the exact angle between the sun and the moon as viewed from Earth. From that, you can then start filling in all of the other pieces of the triangle, which will help us figure out relative distance and relative sizes. Alright, so let's take a look at how well their measurements did. So for the Earth's diameter, so again, this is Eratosthenes using a stick and a shadow and knowing the distance between two cities. He said that the Earth had a diameter of around 13,000 kilometers. The currently accepted value is around 12,756. In other words, he got it. They actually knew anciently how big the Earth was. Then going to Aristarchus, figuring out the size and distance for the sun and the moon. He said that the moon's diameter is 4,300 kilometers. It's actually 3,476. So, not as good as the size of the Earth, but definitely in the ballpark. He said that the sun's diameter was 9 times 10 to the 4th. It's actually 1.39 times 10 to the 6th. So, not as good on this one, but they definitely understood that the sun was really far away. They said that the Earth-Moon distance was 4 times 10 to the 5th, and it is 3.84 times 10 to the 5th. And then the Earth-Sun distance, they said 10 to the 7th. It's actually 1.5 times 10 to the 8th. So again, not as good, but it does show that they did have kind of a conceptual idea that the sun is really big and really far away.